everyone. This lesson extends the idea from the last section on interior angle sum of a triangle. And now we move on to this idea of isosceles and equilateral triangles. Now, before we start talking about isosceles and equilateral triangles, first thing we're going to do is talk about this idea of line of symmetry. Okay, when we talk about lines of symmetry, what is that? Well, it's basically an axis or imaginary line that passes through the center of a shape or object and divides it into two identical halves. Now, what that means is if I look at the three figures below, right, a line of symmetry is if I draw a line down the center here, notice that this half of the figure, if I fold it over that line, it would land directly on top of this. Okay, I can't just draw any line. Like if I drew this line, this half would not fold over and be identical to the other half. So there's only one line of symmetry for this, and it's straight down the center here, right? So that when I fold it over that line, the left side is equal to the right side. The figure in B, same thing. It has one axis of symmetry, and that would be right down the middle here. The next one actually probably has two lines of symmetry, right? If I draw a line through this circle like this whole half, right? If I take this half here and fold it over, it would land directly on the other half. If I take it and fold it a little, or draw it a little differently this way, you should notice that this part here would land directly on this part here. Therefore, the red line could be a line of symmetry also. So a line of symmetry basically cuts it in half. Now, isosceles triangle, probably not the first time you've heard it, but it's a triangle with two congruent sides. When we say congruent in geometry, we mean the measures are equal. The legs are basically the two congruent sides. So if I take this isosceles triangle over here, this is a leg and this is a leg because these sides are marked congruent. So now the vertex angle, right? The vertex angle, when you look at it, is the angle made up by the two congruent sides. So when I look at this diagram over here, right, this angle here is the vertex angle because it's made up by the two congruent sides or the legs. Now what you have to understand is the third side then, right, or the side that's not congruent to anything, is the base. And when you look at the base angles are angles made up by a leg and the base of an angle. So we would say this is a base angle and this is a base angle. So base angle, this is a base angle, right? And that's going to be important down the road. Now, if you read these directions, I'm going to just go through them without pointing this out. But what we're going to do is use GeoGebra to create an isosceles triangle. So basically, I'm going to create a circle first, right? Now, when I create a circle, next thing I'm going to do is draw a segment from the center to a point on the circle. All right. Then I'm going to create another segment from the center to a point on the circle. And then I'm going to go ahead and connect these 2 points. Now, you're probably wondering why I am using a circle. Well, if you look here, if I go ahead and measure the segments, So if I measure this segment, it's 4.3, and this segment is 4.3, right? And if I measure the third side, it's different. So what you need to know is in a circle, AB and AC are both, those are both radii of the circle. And what do we know about all radii of a circle? They are congruent. So to get an isosceles triangle, we use the radii of a circle to get the two congruent sides. Now I'm going to go ahead and measure all the angles. So I'm going to measure this angle, and then the vertex angle. And what I want you to notice here is if I take these angle measures, what can we conclude here, right? If I look at the two base angles, what do we notice about their measures? And no matter what, as I move this around, right, if I change the size of it, the base angles remain congruent, remains an isosceles triangle, right? And the vertex angle will change also. So if I look here, no matter what I do to this isosceles triangle, how big or small I make it, the base angles will always be congruent. So basically what that helps us conclude is the isosceles triangle theorem. And this theorem basically states if two sides of a triangle are congruent, then the base angles are congruent. So if I look at this here, if these two sides are congruent, what I can conclude is this angle would be congruent to that angle. And the converse of that is, if I take the same diagram, if I told you now that these angles are congruent, so if two base angles are congruent, then the sides are congruent. So if these two angles are congruent, these sides are congruent. So let's use this theorem for the next few examples. So right away when you look at example 1 here, okay, if I notice here, they tell me this side is congruent to this side, which tells me right away that this angle is congruent to this angle. So if this angle is 44 degrees, I know x has to be 44 degrees. When I look at the next example, right, if this side is congruent to this side, I know that these base angles are congruent. So if this is 55, I know x is 55. But now, how do I find the measure of angle B? Well, think about it. What do all three angles in a triangle have to add up to? 180. So 180 minus 55 minus 55 would give me 70 degrees. So now the next one, they basically tell us this is 40 degrees. But if I mark the sides that are congruent, you have to recognize that this here is the vertex angle. If that's the vertex angle, to find a base angle, here's what we have to do. We have to take 180, because what do all three angles in a triangle have to add up to? Right? 180. So if I take 180 and I subtract the 40, that gives me 140 degrees. Well, I know if this angle is x degrees and this angle is x degrees, I know they're congruent. So all I have to do is take 140 divided by, 2. And each of these angles would be 70 degrees. The other way you can think about it is if this base angle is x, this base angle is x, the vertex angle is 40, you know all three of those angles have to add up to 180, and you can solve this equation. Right? 2x equals 140, divide by 2, x is equal to 70. Now this next problem is telling us if this base angle and this base angle are congruent, that tells me these sides have to be congruent. So I know x would be equal to 13. Example 5 says, given AC and BC are the legs. So right away I know AC and BC are the legs. of the isosceles triangle. Find the value of x. If those are the legs, what do I know about their measures? That these are congruent. So to find x, all I'm going to do is set those measures equal to each other, and I'm going to go ahead and solve for x. I would get 2x equals 7, and when I divide by 2, x would be 7 halves, or 3.5. All right. So, next, if I look at this, this tells me that these legs are congruent. And if those are congruent, if this is x, I know this is x too. So it's saying find x and the measure of the vertex angle. So to find x, what I'm going to do is take all three of those angles inside, and they add up to 180. So I'd get 3, 4, 5x equals 180. And when I divide by x, right, I would get 36. So I know x is 36, right? But to find the vertex angle, I'm going to do basically 3 times 36, which is going to give me 108 degrees. And I am done. Example 6. If these legs are congruent, find the measure of angle P. So right away, if those legs are congruent, these base angles are congruent. So this would be 3x plus 3. And now what do all three of those angles have to add up to? I know 3x plus 3 plus 3x plus 3 plus 5x minus 2 adds up to 180. So you have 3, 6, 11x. 3, 6 minus 2 is plus 4 equals 180. Subtract the 4, 11x equals 176. And 176 divided by 11 would give you x equals 16. Now, if x is equal to 16, angle P would be 3 times 16 plus 3, which would give you 48 plus 3, which is 51 degrees. So, when I look at the next part, we have an equilateral triangle, right? And what an equilateral triangle is it's a triangle where all three sides are congruent. So if I give you triangle ABC, what type of triangle is it? It is equilateral. Now think about it. What would the measures of angle A, B, and C have to be? Well, think about it. If these two sides are congruent, these angles are congruent. If these two sides are congruent, these angles are congruent. So basically, angle A, B, and C are all congruent. And if you think about it, if angle A plus angle B plus angle C all have to add up to 180, and they're all congruent, I know each angle would be 180 divided by 3 degrees. So each angle would be 60 degrees. So the measures of angle A, B, and C are all going to be 60 degrees. So basically, if a triangle is equilateral, then we can say it is equiangular, meaning all angles are congruent. If a triangle is equiangular, then we could also say that it is equilateral. Okay, we're going to use that idea in the next few examples. Here they tell me this side's congruent to that side is congruent to that side. So right away, I know each angle is 60 degrees. So right away, to find x, all I'm going to do is say 4x equals 60. divide by 4, x is equal to 15. To find y, once I mark all of these angles 60 degrees, these two angles have to equal 180, so y is just going to be 180 minus 60, which is going to be 120 degrees. Example 8, they're telling you all three angles are congruent now. Okay, and if all three angles are congruent, that means all of them are 60 degrees. If all three angles are congruent, we know all three sides are congruent. So the setup to find x is just going to be, if this side is congruent to this side, I'm going to set the measures equal to each other. So subtract 3x, I get 2x. Add 6, I get equals 8. Divide by 2, x is equal to 4. To find y, I know 5y has to equal 60. Divide by 5, y is equal to 12. Then the next example, right? If I look, I'm going to use this equilateral triangle to find the measure of this is 60 degrees, 60 degrees, 60 degrees. Now this box here tells me that angle is 90 degrees, so if this is 60, I know that angle is 30. If this side of the triangle is congruent to that side, and this angle is 30, I know x is going to be 30 right away because these base angles are going to be congruent. And to find y, I would just take 180, subtract 30, subtract 30. It's going to give you 120 degrees. And we are done. Go ahead, try the homework, and let me know if you have any questions.